So lesson 4.7, we're going to look at pages 551 and 552. The profit made by a company that manufactures wind turbines is illustrated by the following graph. The first coordinates represent the monthly number of kilowatt hours of electricity generated by their turbines in millions. We will use the letter X to represent this variable quantity. So again, let's go ahead and highlight that because that looks important. The first coordinates represent the monthly number of kilowatt hours of electricity generated by their turbines in millions. That in millions is important. The second coordinate represents the points are the company's profit in dollars. So we need to use all that information to answer the questions. So first they're asking what the y-intercept of the graph is, and the y-intercept would be around here somewhere. So it looks like 0, we'll call that about negative 60,000. And this information up here will help us know what that ordered pair tells us. So if no electricity is generated, the company will lose $60,000. Okay, so let me move this up just a tad. Then they asked what the x-intercepts of the graph were. So again, that is the point where the parabola is going to cross the x-axis. So I have one here, and I have one here. All right, so those x-intercepts look like they are about 25, 0. And the other one looks like it's about 425, 0. Again, the reason why I say that, it was halfway between the 0 and the 50 over on the left side and halfway between the 400 and the 450 on the right side. So it looks like if either 25 million or 425 million kilowatt hours are generated, the company will break even. Okay, and then they asked us how much electricity would need to be generated in order to make a profit of $100,000. Well, $100,000 is this right here. Okay, so it looks like it crosses the graph here and here. So we should expect 2 points, okay? So let's look at what this looks like. Okay, that looks like 70. And this looks like 380. So let's say about 70 million or 380 million kilowatt hours will generate that profit of $100,000. All right, the last question is, what is the maximum profit the business can earn? Well, that's going to be a Y value, isn't it? What is the maximum profit the business can earn? So back up looking at the graph. It looks like the highest amount is right up there. And that looks about 240,000. Again, we are estimating here. We're doing our best. So the maximum profit is about 240,000. And they would like to know how much electricity needs to be generated to reach that profit. All right, we're going to talk about this a little bit more in the future, but since we know that they're symmetrical, I don't even have to look at the graph for that. Since we know that these parabolas are symmetrical, I know it'd have to be halfway between the 70 and the 380. So 70 plus 380 gives us 450, divided by 2 would give us 225. Now let's go up and validate to see if that's true. Yep, that appears so. Sorry about that. Don't quite know what happened. Well, I don't really want to fix that. So we're going to have to say, pretend I'm writing down at the bottom. The maximum profit is $240,000 and 225 million kilowatt hours needs to be generated. All right. Next page. Says a function that describes the profit made by the company is f of x equals negative 6x squared plus 2,700x minus 63,750, where x represents the amount of electricity generated in millions of kilowatt hours and f of x is associated profit. It says use a graphing calculator computer program to recreate the graph from this problem. Use a trace and or table function to verify your answers. Now you can go to the Desmos app on your phones and you can do that. Just make sure that your window is appropriate. And again, we generally looked at the previous graph generated on page 551 to do that to help us with our window. Okay, let's see what we have here. It says a function in which the variable appears to the second power and no other power except perhaps first is called the quadratic function. So a function is quadratic if it can be written in the form of f of x equals ax squared plus bx plus c, where all of a, b, and c are real numbers, and a cannot be 0. If a is 0, then it doesn't have the x squared anymore, does it? Then it stops being a quadratic function. So I apologize that it seems like everything we need is missing below this page, but we'll make do. So I'm going to go ahead and quickly write down what we had there. Okay, I got that done, and what the instructions asked us is to determine which of the following functions are quadratic. So before, the paragraph before that said, notice that our definition of quadratic function a cannot be 0. This is because to qualify as a quadratic, a function has to have a term with a variable squared. If a is 0, that term is gone, but b and c can be 0, which tells us that the other two terms may or may not be there. Notice also that the definition says can be written in that form. Sometimes you might have to do a bit of simplifying to recognize a quadratic function. Okay, this 16a is written in that form exactly. Okay, so therefore we're going to say that yes, that is quadratic. So we'll say that that's quadratic. Okay, and then with this next one, it can be written in that form if I put that negative x squared first. And notice again that our c is missing, but that's fine. This has to be there, so that is also quadratic. All right, c is not quadratic because you will know that that largest power is to the third power, and for it to be quadratic, the largest power would have to be squared. So no on that. All right, D, we have to simplify that as they suggested. 2x squared minus 8x. All right, so our x squared is the largest power, so that is a quadratic equation. Okay, E looks a little tempting there. Sorry, this is E. But it's not a quadratic because this right here, technically this means x to the 1/2. And so, no, this is not a quadratic function because that x is not to the first power. So that is a no.